Here we have the alternating series of negative 1 to the n times 6 to the n divided by n plus 1 factorial. And we want to use the ratio test to show that this series converges. And the ratio test says that if we want to show that it converges, then we need to show this. So we need to show that the limit of a sub n plus 1 divided by a sub n is equal to a real number less than 1. And so first, let's get a sub n. Now, since we're doing the absolute value, and so the negative 1 won't matter, because absolute value of negative 1 will be just 1. And so we can go ahead and drop the negative 1. And then a sub n plus 1. Then in the place of n, we put n plus 1. So this n right here becomes n plus 1, and then this n becomes n plus 1. And then rewrite this. This is the same as 6 to the n times 6 to the first. And the bottom we get n plus 2 factorial. Once again, since we're dealing with absolute value, we can go ahead and drop the negative 1, because absolute value of negative 1 will be just 1. And then let's go ahead and expand this. This right here, this is 6 to the n. And then n plus 1 factorial means this is n plus 1, and then subtract 1, and we get n. And then subtract 1, and then we get n minus 1, and then we just subtract 1 all the way down to 1. And then this becomes 3, 2, 1. And then the same thing here. The only difference is instead of starting with n plus 1, we start with n plus 2. So that would be 6 to the first, which is 6. And then right here, instead of starting with n plus 1, we need to start with n plus 2. So n plus 2 factorial, it just means n plus 2, and then subtract 1, we get n plus 1. Subtract 1, we get n. Subtract 1, we get n minus 1. And then all the way down to 3, 2, 1. And then now we need this ratio right here. And so this is a sub n plus 1. And this is a sub n. And then right here we can see that this 6 to the n, it will cancel out with that 6 to the n. And then all of this will cancel out with all of these. So what's left is 6 dividing by n plus 2. So this ratio is 6 divided by n plus 2. So this right here is equal to 6 divided by n plus 2. Now, n is a positive number, and so this quantity is positive, and so we don't have to have the absolute value, because absolute value of a positive quantity is the same thing. And then now we need the limit of this. Ratio, but this is equal to 6 over n plus 2. And then this be 6 divided by infinity, which is 0, which is less than 1. And so we have shown that the limit of the ratio n plus 1 divided by n is less than 1. And that's what the ratio test calls for. So we can show that the limit of a sub n plus 1 divided by a sub n is equal to a real number less than 1. Then we can say that the series a sub n converges absolutely. And so now we can say that converges absolutely. And if the series converges absolutely, it means that it also converges regularly.